Hello and welcome to the Advanced Vehicle Maintenance System presented by the Neos Engineers Group. My name is Justin. I own the ScanBot portion of this design. My fellow engineers will introduce themselves and their robots now one by one.
My name's Grant Larson. I built Rotobot.
My name's Alex Westwood, and I built Petrobot.
Genies, and I built the tire pressure bot.
I'm Rob Garcia, and I did the LiftBot.
Thank you. We'll now go through the next couple of slides. We'll go over an introduction, problems, customer solutions. We'll go over our robots one by one. We'll do a virtual demonstration of how they work together in the system. And we'll finally conclude with some benchmark and key points in the conclusion.
Our world has become very car-centered, close to 2 billion vehicles worldwide, and our solution looks to make vehicle maintenance year over year faster and cheaper.
Our clientele focus is in the private, business, and government sector, and their issues are large fleets, expensive repairs, and slow maintenance, and here are solutions for those problems.
The solutions for this is automate the 5 key steps in repair process and allows technician to process more cars per hour, thus increasing repair quality.
AVMS will utilize 5 main robots in its system. We'll use a LiftBot, a Petrobot, FreddyBot, Rotobot, and then a ScanBot. Going through those robots one by one, the ScanBot is a quadcopter drone that will fly a 360-degree view around the vehicle utilizing AI camera, various sensors. It'll create a virtual model. It'll also identify any damages and leaks and upload those to create a vehicle repair plan.
The Rotobot is a tire rotation robot with 4 mechanical wheels for omnidirectional movement, 2 arms to lift and lower the tires, a roller to index the tire, 3 cameras for navigation, a clamp arm to secure the tire, and a lug installation and removal tool, as well as including a wall-mounted tire rack, and it is responsible for changing tires from right to left and left to right for both the front and rear axles respectively.
Next up is the FreddyBot. It is equipped with an LCD screen. You can see the pressure on it and also cameras. What this does is just check the tire pressure on each vehicle tires and inflates and deflates it according to manufacturer's specification.
The LiftBot utilizes a motor and various sensors and will raise and lower the car based on various signals it receives and sends throughout its process.
The Petrobot has a couple different sensors, motors and a distance sensor for movement, servos for the robotic arm, and another motor for the multi-tool for rotation and pumping oil.
The collaboration portion of this begins with the technician first driving the vehicle into the service bay on top of LiftBot. Once the position has been confirmed, the technician will get out and input the vehicle's information, such as manufacturer, year, and model. That information will then be sent to each one of the respective robots, such as the Petrobot for oil type and oil weight, and FreddyBot for tire pressures. The process, once that information is then be sent, a start signal is sent, which indicates for LiftBot to then raise the vehicle. Once that has been confirmed, a signal is sent over to Petrobot as well as Rotobot to begin their respective processes. Rotobot will begin by moving from one side of the vehicle, removing the tire, storing it on a rack before moving to the opposite side of the vehicle, removing that tire, reinstalling it on the opposite side, and then taking the tire from the rack and putting it back on the opposite side. Then it repeats this process for the rear axle. Petrobot accomplishes its goal by removing the oil from the bottom of the vehicle and draining it using a vacuum system. Once both of those systems have been completed, they will then send a signal over to LiftBot, which then lowers the car and allows for FreddyBot as well as Petrobot to receive their signals to begin starting their next processes. FreddyBot moves from each corner of the vehicle using the previously gained manufacturer data to fill each one of the respective tires to their correct tire pressure. And Petrobot uses its previously gained manufacturer data to correctly fill the right type, oil type, and oil weight and capacity into the vehicle. Once those processes are completed, they then return back to their home bases and send a start signal over to ScanBot. ScanBot uses the previously collected information from all of the robots as well as its OBD2 sensor in order to scan the entire vehicle, does a 360-degree scan of the entire vehicle. Once that scan has been completed, it will then return back to its home base, send its packet of data back over to the technician, as well as indicate a service completion signal.
Some competing solutions to our system are service shops and people who do the maintenance themselves. So why should you choose our system? Our robots have long service life, save consumers cost per vehicle, and save high-skilled technicians time for other major tasks.
To wrap us up, we think AVMS is the next revolution in the auto industry. It's going to make vehicle maintenance fast and easy.
Consumers will see a yearly cost of ownership decrease, and overall safer systems will save lives on the road. And this concludes our presentation on our advanced vehicle maintenance system presented by Team Neos Engineers.